Seipel Dome, this is the record Kendrick Taylor has come to recover.
This is our drill. It has an electric motor, and you can see these cutting surfaces right there. And then as the drill is lowered down, the core just kind of forms right up in the center there. I sort of have a love-hate relationship with this drill. When it's working well and giving me good ice core, I really love it a lot. But lots of times it's kind of finicky, and then I'm not so fond of it.
But it has been producing the cores.
Woo, good one. Good job, Earl.
Things are going very well right now. We've been drilling for a couple days. This is the second core that we're working on here. Core quality is very good. Weather's very nice for drilling at this time.
And the cores will not only show if the ice sheet was here in the last interglacial, they should also show what the climate was.
The reason we're interested in understanding the climate is that it's going to tell us how much snow was falling, what the temperatures were, and that's going to allow us then to understand the relationship of climate and the ice sheet stability.
Junior!
The snow traps a record of atmosphere and climate, which is preserved in annual layers. This core represents about 2 years.
Well, we're down here starting to process the ice cores. We're going to be measuring the length of these cores, the density, by measuring the weight and diameter, and then we pack them up in tubes for shipping off.
In the labs, they'll analyze dust and gases that get trapped in the ice. These will show how cold it was and date climate change. And these cores will provide the test for Doug McHale's model.
Got another nice one.
Ice cores are perhaps the most valuable things that come from ice sheets. Why would we care to use an ice core time series? Why would we care about the past behavior of the ice sheet? Well, if we can retrodict the past behavior of the ice sheet coming up through time towards the present, then maybe we have a chance to accurately predict how the ice sheet would behave in the future.
It's the ultimate goal of the modeling process, and it's imperative. The climate data already in from cores in Greenland shows the Antarctic ice sheet may have to face extraordinary levels of climate change. Kendrick Taylor worked on the Greenland project too.
We've been working up there a lot recently and found some very interesting results up there. We found evidence of climate changes somewhere between 10 to 14 degrees centigrade in a period as short as 40 years. Now that's a really large change, really rapid change. You may not have sort of gradual transitions between a warm condition and a cold condition, or between a warm condition and an even warmer condition in the future. You may have a very sudden and abrupt change, and that would be catch a lot of people by surprise.
They'll have to wait for the cores to be processed to find out if this change happened in Antarctica.
Yeah.